So, Crafter finally has Redstone, and I can already hear what you're typing. What's the difference between this and Miscons, or did you modify Miscons, or why did you copy Miscons, or what's the difference, or what are the benefits of this over Miscons? So Miscons is a binary system. It's on or it's off. So this is a leveling system, as in there are power levels in each one of these nodes. So we start off at level 9, which is a source, and we go off gradually. We have level 8, 7, 6, 5, 4, 3, 2, 1, 0. 0 is the off state, and even power level 1 can power things. I've got to make it a little bit darker, but overall it looks pretty good. So the differences between this and Miscons are Miscons has one essential power delivery system, which is the Miscons wire. This has two separate levels. So on our lower level, which we're going to make redstone drop, is the redstone dust. And you can place that down, and as you can see, the leveling decreases as it goes on. And we can disconnect that from the circuit and reconnect it. So if we remove our power source, all of our stuff goes to level 0. And we put that back, it all goes back. As you can see here, since I'm using the rail-like draw type, it appears that this should go up, but it does not, because technically this dust and the wire is a binary direction. What that means is there's up, down, left, right, forward, backwards. There's no upwards, sideways, or corners or anything like that. And the benefit of that is it makes making complex machinery a lot easier. And you'll see that when I show you the wire. So another thing with Miscons is there's no real way to do simple locks or devices or machinery that uses leveling of the wire. You have to do a Miscons controller and program it with Lua instead of doing a physical object. So with this, I could implement a weight or a scale, or I could have the doors output a certain value, power level, or I could make a chest output more the more stuff that is in it, and stuff like that. You could also have, let's say I have a piston right here, I could have it push like a wire into this, or something like that, to change the value, and you can make complex locks like that with levers and stuff once I implement those. So as you can see, this doesn't go up. I'm pretty sure I already explained that. This is like the third time doing this video, so because the dust, you can't really place dust on the wall, so you can't actually make the dust go upwards, but that's where the wire comes in. So if I just place a wire here, as you can see, it lights up. It's got the trailing value as if you would put some dust here, but the difference between the dust and this is you can go upwards. And it's a little tricky right now. I haven't set the node blocks to the full size value. I'm kind of tempted to keep it like this because it's kind of easier to work with in complex machinery, but you can just simply do what you did before and do that, and now this powers everything else. And it's actually very nice the way it all fades together. It's pretty cool. Again, with the rail type draw, the rail-like draw type, I can't make these two connect or look like they connect. But overall, it's pretty nice. So we have the blinky. I haven't actually implemented the blinky torch yet, and I'm going to essentially use that code to make repeaters, so you can have stuff that just goes really far away into unloaded chunks, essentially. But so what are the main differences in between having a binary and non-binary direction? So let's say I wanted to, I don't know, let's say I wanted to have something go up here. So I could do that, like that, and then I could have a, let me put something here so it's a little bit easier to see. I could have a piston push this, and that will disconnect the circuit, or I could have a locking block, which eventually I'll put in, that takes an input. And so if you have it go over to here like this, and of course I need to use a wire, even I forgot about that. And let's say that the locking block is right here, or no, I'm sorry, that would be right here. And the locking block is all powered. It could block the circuit from continuing based on some physical thing that you have set up. So hopefully this explanation of what I'm planning to do with this makes any sense at all. So feel free to test it and check if there's any bugs. I'm pretty sure there are at least a couple of bugs, because even though this is a very simple implementation of this, it's still kind of complicated in the way that it works. Essentially, it's a recursive check, and it, yeah, see, look at that. I already found a bug. And if for some reason that is powered, I don't know. I had this set as an ABM, but the ABM manager was like just dumping terminal output because I was outputting this every second to check power levels recursively. And even though it didn't lag, it was making the terminal unusable, so I couldn't really debug anything. So that's the redstone. I mean, it works kind of. There's just nothing to do with it yet. So hopefully in the future I could utilize this to make just crazy machines possible. So that's just a little update. I'll see you guys in the next video, which should be the short one I'm about to make. So see you in a bit.